Welcome to engineering drawing. Continue video lessons. So in this we are going to learn example 22 with the continuation of previous example 21 in orthographic projections. Note on this importance also. How to draw the third view of an object with a given two views of the object. Practice on visualizing the object from the two given views, adding the third view. So these are the objective behind we are going to learn with this topic, with these examples, that is 22. So here we are given the example 22, the problem number 1. Draw the third view of the given object. Here the orthographic views are given. So please note on the orthographic view, that is front view, and top view is given. So with this we have to draw the third view of object. Orthographic view of the given object is shown below. Note down. In this explanation, note down the steps, and with the steps learn how to draw in the third view.
Example problem 22, problem 1. In this problem, the front view and top view of an object are available. Having the two views, our task is to complete the right side view. Draw the meter line. Draw projectors horizontally from the front view and through the meter line from the top view and complete the right side view. In the right side view, show the hidden details by dotted line and represent the dimensions appropriately.
Once again,
Example problem 22, problem 1. In this problem, the front view and top view of an object are available. Having the two views, our task is to complete the right side view. Draw the meter line. Draw projectors horizontally from the front view and through the meter line from the top view and complete the right side view. In the right side view, show the hidden details by dotted line and represent the dimensions appropriately.
note on third view. This is the final answer. This is the solution. Problem number 2. Draw the third view of the given object. First note on the problem, orthographic view of the problem. From this, you draw the given object of third view. In this solution, also, you note on this one, this is the third view.
Example problem 22, problem 2. In this problem, the front view and left side view of an object are available. Our task is to complete the top view of the object. Draw the projectors vertically downwards from the front view and through the mitter line from the side view. Now complete the top view and show the dimensions appropriately.
Now done. Once again, problem number 2, example 22.
Example problem 22, problem 2. In this problem, the front view and left side view of an object are available. Our task is to complete the top view of the object. Draw the projectors vertically downwards from the front view and through the mitter line from the side view. Now complete the top view and show the dimensions appropriately.
Now done. Once again. Now done with these questions. Meter line. Meter line is used to draw side view. So in this, C answer is correct. And one more, true or false. For some components, left side view will same as right side view. False. True. Some components. Note down frequently asked questions, which is the most important one at the point of examinations. Next example, 23. So with this, the objective will be fill up our objectives behind this one to identify the object from the given orthographic views of the object by comparing the surface profile with pictorial views of different objects. So now done, that's the example 23, identify the surface on the views with reference to the object. True or false? By only comparing the front view of the object with the front surface profile, the object can be identified. False. If the object is having different profile in three different directions, all the three views are to be compared with the appropriate surface profiles to identify the object. Is this true? This one is true. Note down frequently asked questions. Identify the surface on views with reference to the object. Object 1, object 2, object 3. Its views. Now the next chapter is the above objects. Identify the object. Front view, left side view, top view. Introduction to sections. Here we will discuss introduction and classifications of sections. So with this, after completion of the introduction of sections, we are going to learn, that is, objectives behind the sections topic is the need for sectioning a solid, meaning of section, sectional view, true shape and apparent shape of section, norms in drawing sectional views, meaning of full section, half section, partial section, revolved section, removed section and offset sections. So these are we are going to learn in this sections topic. Introduction. Need. The orthographic projection hidden. Details are given or shown by dotted lines. In case of solids with the complex inner details, so the details are shown by dotted lines. Interpretation of such views will be difficult and confusing. It is a normal practice to assume that the solid is cut in the two halves of the portion of the solid between observer and the cutting plane is removed so that the inner details are exposed to the observer. The same can be represented as view called sectional view. Section. It is a surface obtained by cutting solid with the cutting plane. Note. Section should be hatched with equally spaced 45 degrees inclined lines. Note down this section. Here the cutting portion removed, section plane, section and portion remaining, that we can see the section. Sectional view. It is the portion of the section together with the remaining portion of the solid. True shape of section. It is a section obtained in a plane parallel to cutting plane. The view direction is perpendicular to the cutting plane. That is a true shape of section. It is a section obtained in a plane inclined to cutting plane. The view direction is inclined to the cutting plane. First note on this one. This is the true shape, true and apparent shape directions, sections. Then next, sectional views. Note on this sectional views. Then continue. The imaginary plane is called cutting plane or section plane. It is generally assumed to be parallel to the plane on which the view is projected. The sectional view thus shows not only the shape of section but also all the visible edges and contours of the object behind the section plane. The section is indicated by means of hatching or section lines. Dashed lines for hidden details are omitted from the sectional view. The sectional lines should be drawn evenly spaced and of uniform thickness. The section lines must be gray color. The section lines should be drawn with a 3H or 4H pencil. When section is assumed in one view, it does not in any way affect other views. The other views are drawn as if the entire object exists as a whole. Only the cutting plane line is included to show the location of the section and the direction in which it is viewed. The position of the cutting plane is indicated by the cutting plane line. Classifications of sections. Sectional views may be further classified as full sectional view, half sectional view, half set sectional views, etc. Section, as shown in figure. Full section, the object view resulting from passing the cutting plane completely through an object. Note on the figures, full section and half section. In some cases, it is better to illustrate internal features with both section and a full view. In this case, we can cut away only part, that is quarter of the object, and draw view that is half normal, half section. A section view resulting from an imagined cut that removes only a portion of the part length. This method is well suited to symmetrical parts with section starting at the axis of symmetry. Now done the half sections.
Section. In this video, we will see the meaning of half section. In this, 1/4 of the solid is removed by two cutting planes and the object is projected as such. As a result, 1/2 of the solid will be shown in section and the other half will be shown in ordinary orthographic projection.
Now done. Classification of sections. Partial or broken section. When only a small portion of an object is required to be shown in section to reveal a minute feature, the view is shown in partial or broken section. Please note down. The irregular lines shown the boundary of section. This section is also known as local section. A revolved section. A section is formed by passing a cutting plane at right angles to the axis of object is called a revolved section. Note down figure. It is fact the cross section of the object in this section is then revolved. This section is revolved, then revolved and brought into the plane of axis and shown in the view in which the axis is seen as a line. That is figure 9a. The section shown in this manner is called revolved section. The outline of revolved section, when it does not coincide with the outline of view, is shown by thin continuous line. Removed section. This section is obtained in the same manner as in the revolved section, but is drawn outside the view, generally around the extension of the cutting plane line. That is 9b. A sectional view resulting from an imagined cut does not follow a straight line. Offset sections are used to include features that do not reside on a straight line. The cutting plane for an offset section is stepped or offset at one or more right angle bends, but will eventually cut through the whole object.
Offset section. In this video, we will see the meaning of offset section. It is a section obtained by cutting a solid with a cutting plane which is not following a continuous path. Instead, it will have an offset as shown in figure. As shown, the cutting plane passes through the hole in the left part and it doesn't pass through hole in the right half. Accordingly, in the section, in the left half, the hole is clearly visible and no hole comes in the right half.
Removed section. This section is obtained in a same manner as revolved section, but is drawn outside the view, generally around the extension of cutting plane, line 9B. Section view resulting from imagined cut does not follow a straight line. Offset sections are used to include features that do not reside on straight line. The cutting plane for offset section is stepped or offset at one or more right angle bends, but will eventually cut through the whole object. Please note down all these points for future reference. Note down offset section, figures. Note down quiz questions. The surface obtained by cutting solid with a section plane is A sectional view, B section, both A and B, none of the above. Answer B, that is plane section. Surface obtained by cutting a solid with a section plane is section. To get a true shape of section, project it onto a plane dash to the cutting plane. Parallel, perpendicular, inclined, none of the above. Answer is parallel to cutting plane. True or false questions. In half section, it is assumed that 1/4 of object is cut by two cutting planes or removed. So true or false means it is true. Now the next topic is sectioning conventions. Sectioning conventions and representations of the materials we are going to study in this. Sectioning conventions. Bolts, nuts, studs, rivets, pins, keys, cutters, shafts, etc. are never shown in the section longitudinally. That is, when the cutting plane passes in such a way as to contain their axis. They are, however, cut and shown in cross section. That is, when the cutting plane is at right angles to their axis. Spokes or arms of wheels or pulleys are never sectioned longitudinally. The cutting plane is assumed to be offset so that the arms are left intact and behind the cutting plane. So no doubt this sectioning conventions. Arms of the wheel like this. Similarly, a web or a rib is also not shown in section. When cutting plane cuts it along with its length or breadth, it is left intact by offsetting the cutting plane. Note on the figures. Sectional view of wheel having odd number of arms. The arm B is shown in its true projection. In conventional practice, this arm is assumed to be revolved and brought in line with arm A as shown in figure 2. This makes the view comparatively simpler. Shafts pipes, etc. of long lengths are generally shown broken in the middle to accommodate their views in drawing sheet without reducing the scale. Conventional methods of showing broken ends are round bars or shafts. I shown first note down pipes, bars of rectangular and square cross section, wood scantling, hatching or section lines. Section lines are drawn in the section, that is portion which is cut by the section plane. The section line are thin, continuous lines drawn included at 45 degrees to axis or to the main outline of section. Note down the figure and note down the matter also. Hatching lines, note down. They should be spaced uniformly throughout the drawing. Section lines should never cross an outline of drawing. They should be interrupted for dimensional only, not for dimension lines or arrowheads. Section lines in two different pieces in contact should be drawn in opposite directions. Note down that figure also. Very thin sections are shown totally block, leaving thin space between adjacent sections as shown. Conventional representation of materials in section. Note on this table, the different metals and materials are conventionally shown in section by different types of section lines as shown. Note down all item, figure and explanation regarding, that is application regarding. Note down lost the table. Section conventions to be adopted and conventional representations of different materials in section or shown in a table. This is the summary of this topic. Now note down true or false questions. Boards, nuts, rivets, keys, etc. are never to be shown in longitudinal text section. Yes, it is true. Long piece, second one. Long pipes can be represented with the broken ends. Yes, it is also true. Section lines, hatching can cross the outline of drawing. No, it is false. Here, an example of a section. Now done the example 1 of a section. A cube of 45 mm side rests with a face on HP such that one of its vertical face is inclined at 30 degrees to VP. A section plane parallel to the vertical plane cuts the cube at a distance of 15 mm from the vertical edge nearer to the observer. Draw its top and sectional front view. So with this, we are going to note down first example 1. Now with this, we are going to see in a three-dimensional view and then note down the step by step in solution. And the figure is also given like this.
Example 1. In this problem, a cube is resting on the ground on one of its faces such that all the vertical faces are equally inclined to VP. The cutting plane is parallel to VP and is cutting the cube 15 mm away from the observer.
Now next, solution of the example 1.
Example 1. Solution. Draw the projections of the solid as per the given position. Show the cutting plane as a line in the top view. As the cutting plane is perpendicular to horizontal plane, it will be seen as a line parallel to XY and show it 15 mm away from the vertical edge B1B. Give notations 1, 2, 3, etc. for the various cutting points. Project the cutting points 1, 2, 3 from the top view into the front view in the appropriate edges. Join the projected cutting points in proper sequence in order to get the section and hatch it. Darken the retained portion of the solid in both front and top views.
Note down complete figure. With this, we are going to stop here. We will continue in the next class. Thank you.